Hello, this is Group 19 presenting the Valley Skyscraper project. The scope of the project are material selection, structural loads, structural element dimensions, structural element typical connections, and robustness checking. The skyscraper will be the world's tallest timber building located at 42 Valley in Brisbane. It is for residential use and have the design lifetime of more than 50 years. It will be 50 meter wide, 30 meter long, and 92 meter high, which consists a total of 30 floors with 29 3-meter floors and one 5-meter ground floor. The structure is designed with accordance to AS 1170.2, AS 1170.1, and AS 1720.1. The overview of the building is shown on the right-hand side, and the exterior wall will be glass. The core structure is softwood, as it has a greater flexibility in plane arrangement and a higher resistance to lateral load than hardwood. Two major timber materials will be applied to the structure: glue laminated timber and laminate veneer lumber. GLT is used for beams and columns. It has a chiring rate of 0.7 mm per minute, so the fire resistance rate is less than 60 minutes. For the slabs, wall, and bracing, CLT is more suitable than LVL, as it can distribute the load better. However, CLT resource is very limited in Australia, and it has not yet been covered in the code. Besides, this building is designed to have one-way slab. Therefore, LVL is used instead of CLT, and it has a chiring rate of 0.6 to 1 mm per minute, with a fire resistance rate of 30 to 60 minutes at 300 degrees Celsius. During the design, 3 major loads are considered: dead load, life load, and wind load. Different load cases are also calculated with the accordance to AS 1170.1 to obtain the worst case, which is permanent and shorten imposed actions. This is the dimension and material to be applied to each section of the structure. On the right-hand side, there is a plan view of the structure, and it is the same for every floor. In the middle, there is a LVL core to increase resistance of lateral load. Elevators and emergency ladder are located in between the core. This design also provides appropriate distance for every unit to escape under fire condition. Shear walls are also installed to provide lateral load resistance, as well as support vertical loads. The strength checking will focus on the critical elements. The largest span is 30 meters, but this will be too long for the beam. Thus, the beam is separated to 3 parts with 10 meters each. The internal shear walls are used to increase general robustness and separate residential units. Bolts, coach, screws, and timber connectors have higher capacity than nails and screws. Therefore, bolts are most suitable for this residential timber structure, which large loads are imposed. It is used for connection of beams to other elements, such as column, slabs, and bracing. Additionally, the shear strength of timber is only 1/10 of the bending strength, and bolt holes may also decrease the shear capacity. Thus, shear plates are adopted to provide additional shear strength. Dowel is applied to beam-beam connection since it can provide a flat and smooth surface. The structural stability and strength are checked by both hand calculation and simple spec-gas modeling. Beams and columns are complied with the ultimate limit state design according to AS 1720.1. This includes bending, shear, and compression. For the slabs, the deflection is checked with the serviceability design. Thank you for your listening.